Okay, today our topic is engineering surveys. So before any highway alignment is finalized, first we have to study or we have to go for engineering service. After the engineering service, we can finalize the highway alignment. So the most important engineering surveys are map study, recognition survey, preliminary survey, final location and detailed survey. Okay, map study, recognition, preliminary, detailed survey. So in this manner first we have to study each and everyone. Okay, in this way, in the first most important is map study. So in order to in this engineering service, each stage should be uh, remember in this manner only. That means first you have to write a preliminary survey. It may not correct answer for your engineering service. First you have to study and you have to write the map study, then recognition survey, then preliminary. So in order to sequence order of this surveys, we have a small shortcut method, that is MRP, the maximum retail prices. Shortcut method is MRPS, maximum retail prices. Map M means map study, R means recognition survey, P means preliminary survey, and final location and detail survey. This is the shortcut code for remembering about the sequential order of the engineering service. Because the most in competitive exams and all other exams, they are asked about the what is the second stage in the engineering service. Directly they ask about the what is the second stage in the engineering service, and also what is the third stage in the engineering service. Like this way they are asking the they are asked in the question. So this is the important process you have to remember only in this manner only. Okay, so and also I will give very shortest discussion and shortest view for the uh, so from here it is one point and it is Hyderabad. So come on to Hyderabad. So we have to propose a alignment. So in this process, is a map study is a online inspection. Simply we say that it is a map study is a online inspection. From the online inspection, that means topographical maps. From the maps, we can observe the more number of alternate several possible alternate routes from source to destination, that is from Khammam to Hyderabad. So from Khammam to Hyderabad, we have so many alternate possible alternate routes are available from the topographical map of India. From this map study, we can these all type of possible alternate several possible alternate routes are gathered at one place. Next one, after map study we have recognition survey. In this recognition survey, they choose the it is a recognition survey is a simply is a physical inspection. Map study is a online inspection. Recognition survey is a physical inspection. Among the survey party, some minor instruments they are taking along with them. So and travels along these from the map study of several possible routes, and finally they conclude the which alignment is better from the almost above the all possible alternate routes. Okay, from this recognition survey we can find the most feasible routes from the map study. So in recognition survey, the field party going to the site and takes minor instruments, and from this minor instrument they are calculated and physically inspected, and finally what are the most feasible routes for the source to destination. Next one, preliminary survey. Again in this process we have also they are taking the in the preliminary survey, it is a selection process. Simply preliminary survey is a selection process. In the selection process, they are choose the what is the best in this two alignments, which is the best one. They compare in preliminary survey, they compare the what are the best elements among the two or three, maybe maximally two or three alignments on after the preliminary survey is conducted, and compare the differences between these alignments, and finalize finalize the best alignment in the preliminary surveys. After the preliminary survey is completed, next the final location and detail survey is this process is selection of the final alignment. In this finalized alignment, they constructed each and every parameter and finalized the data, and final element is placed on the ground, and also detailed surveys are conducted and designs also conducted, and finally we go for construction. So this is the main process generally follows in the engineering surveys. So map study is a online inspection. From the map study we can choose most possible alternates from the topographical maps. Okay, next, recognition survey. This is a physical inspection, so some features are not available in the map study. So from for this, in the map, the show the present existed conditions are, is there not are presented or not. The field party go and check their feasibilities, and finally they can conclude the most feasible routes from the map study. After the recognition survey, preliminary survey. This is a selection process. Among the recognition survey, they find finally they give a three or two possible alternates from the for the preliminary survey. The preliminary survey, they in all routes they conducted the survey and find they compare the difference between these three alignments, and finally they gave the best alignment. The final location is the selection of final alignment. In the final alignment, they can completed they can clear completely of analysis the final location and transfer the final location into the ground, and after that the construction process is uh, started. Okay, this is the main steps which are in the engineering survey. So in this manner, from the map study. So from the map, alternative routes can be suggested in the office in the topography map of the area available. Okay, so from the office from the office only, by the help of topographical maps, these maps are coming from the survey of India. About to contour interval is 10 to 20 meters. From the contour maps, in the field office, in the field itself, sorry, in the office itself, from the maps, they can choose the most possible alternate routes. Okay, among these alternates, so they can choose the avoiding valleys, ponds, lakes, and also avoiding bend of the rivers, and also cross a row of hills and possibility of crossing through a mountain pass. So that means it is simply for example, it is a hill, it is a pond, it is a marshy land. So like this, our proposed element process going through this way. So the element should grow, or the alignment may change to this process. So in from the topographical maps, avoiding the valleys, ponds, lakes, that's why they choose the number of alternate elements, like this way or like this way or like this way. So they choose the different type of alignments by using of the topographical maps, and avoiding valleys, ponds, because valleys requires, if we go through valley, so we have to construct a bridge. So like, from the map study we can observe these points. Next one, map study gives a rough guidance of the routes to be further surveyed in the field. So this is the the most possible in the most feature in this map study. So from the map study we can observe the most possible alternates, and also in these maps we can avoid the valleys, ponds, lakes, and also etc. river crossing of passage of hills. Like, for example, I draw a, so like, there is a series of hills. So in these hills we can, from the topographical maps, we can suggest the alignment through the mountain pass, wherever the pass in between the gap, in between gap between the hills. So from the map study we can observe this type of routes. Okay, next one, uh, recognition survey. So the recognition survey already said that it is a physical inspection. So in this survey, some survey parties, along the survey party, they are survey parties are physically inspect the proposed alternate routes along the map available in the topographical maps, and taking the very simple instruments like upney level, tangent, clinometer, barometer, like all simple instruments are taken along with the party surveyors, and go through the proposed alignments from the topographical maps, and conducted the and count the number of valleys, ponds, and number of cross drainage structures, and length of the cross drainage structure, and what type of cross drainage structure is required. So like all type of data is collected, which is the data not presented in the topographical maps. So the all type of data is collected at one place, and finally, so choose the which type of alignment is proposed alignment is better among the all possible alternate routes from the map study. So and also in the American answer we can find out the high flood level coming from the areas, and also find out the soil characteristics along the proposed elements, and also the geological features. Like, and also if we constructed the if we propose to construct on the place, is there any construction material materials or stone quarries, and also water sources and water availability. So all these type of matters or all type of this information is um, yeah, all type of information is searched and gathered and place it in it on paper and find out the best element from the topographical maps. Okay, so for this all type of surveys, we can finally we get the few alternate elements chosen from the further study. So after the recognition survey, you can go for preliminary survey. So the main objective of preliminary survey is to compare the different proposal in view of the requirements of the good element. So some element is good but it is very costly, some element is costly but it is very badly alignment. So by this way, so which element is better among the most probable alternate proposed elements from the recognition survey. And also the to survey the various alternate proposal after the recognition to collect all the necessary physical information and details of the topography and drainage and soil, so etc etc. So the main thing is the compare the different proposals in view of the requirements of the good alignment from the recognition survey. So recognition, by the recognition survey we can choose the we can it gives the morely mostly they give it gives 3 4 alignments. From the alignments the survey parties surveyed and find out the which element is better from the above recognition survey. Okay, in this in the preliminary survey we have mainly two types of methods, a conventional approach and a modern rapid approach. In conventional approach, so it is a regular process. Some survey parties are carried out, survey parties are flow through the are moving through the whatever the alignment is chosen from the topographical maps along these routes. The survey parties are going through the survey and finally they collected the all information and finalized the best alignment from the all consideration. Okay, this is this is conventional approach. In modern approach, so they don't need of any survey parties or any field parties or maybe surveyors. They all type of surveyors are not required. Just to take an aerial photograph or any drones, we can use the along the proposed route and snap the proposed routes of the area, and finally they get the data and substitute it into the raster or any other software information. They finalize the what type of alignment is present and which is the better one from the proposed alignments. Okay, so in this preliminary survey these two type of methods is available in the preliminary survey. So mainly the in the preliminary survey they conducted the most of the all engineering surveys like material survey, like leveling work, and also geological conditions. All type of surveys are conducted in the preliminary survey. So in this preliminary survey the finally they give the best element from the organization survey. Okay, next one, final location and detailed survey. Among the from the preliminary survey we get two or three best proposed elements. After the two three proposed elements they gave the after the surveys they gave the which is the best element. So by the selection of this best element, so the final location, the whatever the alignment is finalized at the design office, the the alignment is now it is transferred to the ground. Okay, the whatever the alignment is finalized in the preliminary survey, the in the preliminary survey the alignment is uh, fixed or transferring the alignment to the ground. This is done by our regular using of instrument, that is transit theodolite. By using transit theodolite we can control or we can establish the major and minor control points along the ground, and also provide the temporary benchmarks around the temporary benchmarks at the intervals of about to 50 meters, and also maybe at all drainage and underpass structures whenever the drainage or what is we say cross drainage structures and also underpass structures. On this process also we provide benchmarks, because if if do not provide the benchmarks, again we have to again the same process repeat from the starting place. So for this we have to provide at least 250 meters at the place of at the length of the 250 meters we provide temporary benchmark. Maybe it maybe at least we provide at the drainage of structures or underpass structures. In the detailed survey, go for earthwork calculations and drainage details are to be carried out, or and all details are noted in the level book. From the level book, we can calculate the how much quantity of earthwork should be excavated, and how much work of earthwork should be refilled, and how much cross section levels are taken at intervals of 50 to 100 meters, and a detailed survey, soil survey to be carried out, and that means the soil survey including CBR value. So this is the most CBR value in the highway, because of in order to cater the traffic. So the cater of the traffic in terms of traffic volume, it maybe turns into load. So for that type of load, the payment is supported, or payment are resisted about that type of heavy load. So for this, how much thickness of the payment is required, how much depth of thickness is required, so and how much thickness of subgrade soil, subgrade and base subbase soils are required. So with this data, the soil survey data, we can finalize the design of the payment. So all these data gathered at one place, and finally we can transfer the best element, the finalized element onto the ground in this way. So this is the process of engineering surveys. So once again, I am repeating you. So engineering surveys are mainly four types: map study, reconnaissance survey, preliminary survey, final location, and detailed survey. In map study, they by using topographical maps, these maps are coming from the Survey of India about contour interval of 1 to 15 to 20 meters. From these contour maps, we can choose the most possible alternate, several possible alternate routes. So in this map study, we can choose the several possible alternates. From these alternate routes, in reconnaissance survey, some field party, some surveyor party go through these possible alternate routes, and finally they give the most feasible routes among the several possible routes. So from these most feasible routes, they conducted the preliminary survey. In the preliminary survey, they conducted the soil survey, topographical survey, and everything. All type of surveys are conducted, and note down the number of crash drainage structures, and all parameters are taken at one place, and finally that data is put together one place, and finally they compare the different proposed alignments, and this proposed element with they get data and finalize the best element from in the most feasible routes. So finally we get the best element. After the getting of the final element is transferred into the ground by the theodolite, and also provided temporary benchmarks at an interval of 250 meters. This is a process generally goes in the engineering surveys. Okay. So in order to remember these points, maximum retail prices, MRPS. Okay, M means map study, reconnaissance survey, preliminary survey, detailed surveys. So this is the it is a most important. You have to remember. You have to write only in this manner also. Okay. No, if you write on the first preliminary survey, you don't get full marks. Okay. So this is the process generally process. Okay. So next one, drawings and report. In the drawings and report, we have whenever in these all type of surveys, we have gathered data and transfer this data into books. So well, put it in a book. We have so many plans, so many maps are available. So these all together at one place, we get the drawings and report. In this drawings and report, first I have the key map. In the key map, it shows the what is the main features available in the map. That means what are the so it shows the key map shows the proposed and existed roads. That means what are the proposed already physical, already presented roads, and also we have existed roads like presented or existed road, and also in this plan also we have the in this map also we have the proposed road also present in the key map. So proposed road and existed road are presented road. So like all the roads are in the manner. So like if any chief minister came at one place, they give the while showing this map, they can understand the what type of and they can easily understand the how much length of this route, and where is the important cities connecting these places. Like in this key map, they give the okay, they give this type information. Next one, index map. So like key map is a like a textbook front page. Key map is a textbook front page. If we say if any highway engineering on the top of its cover page of the book, we can identify. So this is a highway engineering book. So it is related to totally in this syllabus completely related to say highway engineering. So like this way, key map gives the most feasible information regarding the proposed and existed road, and its size of the key map is 22 by 20 centimeters. Next one, index map. It is like a index of the textbook. In the index of the page, so you don't go from you don't need of throughout the textbook and refer the all pages. Just you have to go the index page. You can observe the what are the units are available in the, what are the syllabus presented in the textbook. Like index map also shows the what are the basic information, and in terms of its topographical area, and also gives the symbols. And also this plan may be size of 32 by 20 centimeter. Index map gives the main features, that is the topographical area of the topographical features of the proposed element. Next one, preliminary survey plans. Next one, preliminary survey plans. In the preliminary survey plans, it shows the various alternate elements data. Like in preliminary survey, what we say, just we have take more than 2 3 elements are taken. Along these 2 3 elements, we take the surveys and gathered at one place, and all these plans are placed at one place. So these are the preliminary survey plans. The scale of this preliminary survey may be 10 centimeter 10 centimeter to 1 kilometer, and 25 centimeter to 1 kilometer also. Next one, detailed plans. In detailed plans, it shows the ground plan with the alignment also. In detailed plans, what we say, detailed plan is the final plan, final element. In the detailed plan, we go for it shows the ground plan along with the alignment and the boundaries and the contours intervals of about very accuracy about 1 to 2 meters. Okay, in the detailed survey, it gives the contour interval about 1 to 2 meters. In the map study, we can get the only contour interval of 15 to 20 meters interval. In the detailed plan, we get the contour interval of 1 to 2 meters. In this size of this plan may be A2 size paper. Okay. Next one, longitudinal sections and cross sections. In these longitudinal sections and cross sectional plans, we shows the datum line, existed ground surface, vertical profile of the proposed road, and also position of the drainage purpose and the cross structures. Okay, so in these all in the longitudinal plans and the cross sectional plans, we can finally indirectly we get the how much soil to be excavated and how much soil to be refilled, or how much soil should be placed on this place. Okay, and also it gives the land acquisition plans. Like if you see this any in newspaper, the most of the బావులు ఇన్ని ఈ భూమి తీసుకుంటున్నాము, ఇన్ని చెట్లున్నాయి, ఇన్ని ఇట్లున్నాయి అని చెప్పి మనకి ఒక నోటిఫికేషన్ ఇస్తారండి ఒక పేపర్‌లో. ఈ ఈ ఈ ప్రాజెక్ట్ కట్టబడుతున్నాం. ఈ కట్టబోయే ప్రాజెక్ట్‌లో ఈ ఫీచర్స్ అన్నీ ఉన్నాయి. పలానా వ్యక్తివి పలానా ఉన్నాయని చెప్తారు. సో, ఎందుకంటే గవర్నమెంట్ కంపెన్సేషన్ చేయడానికి. ఎవరెవరి దగ్గర ఏమేమి తీసుకున్నాం, ఎంతెంత ల్యాండ్ కలెక్ట్ చేసుకున్నామో ఆ ల్యాండ్ ఆ పేపర్‌లో కరెక్ట్‌గా ఉండాలి. లేకపోతే మనకి పరిహారం అంటే దాని కంపెన్సేషన్ అనేది గవర్నమెంట్ నుంచి తక్కువ వస్తుంది. సో ఇన్ ఆర్డర్ టు ఫైండ్ ది ల్యాండ్ అక్విజిషన్ ప్లాన్స్, in a land acquisition plan, so the total information regarding the along the proposed element, the what are the features we have to acquisition for the proposed element. So may like wells, trees, and also like all type of building structures, all all should be gathered it in the land acquisition plans. Next one, design of cross drainage structures. In the drawings of cross drainage structure, like after the detailed location, detailed plan and the detailed diagrams in the alignment, so we get the cross drainage structures. And the cross drainage structures, we have the in the details, the cross drainage structures, what is the length, what is the thickness, what are the dimensions, what is the concrete type of used, and what is the type of steel used, and how much time diameter is used for the in the construction of the cross drainage structures. So all type of parameters, all type of information is available in these drawings. Next one, drawings of road intersection. Like at present you don't have the syllabus, in the future you get the road intersection. In this road intersection, partially uh, intersection and unchannelized intersection, channelized intersection. In between intersection, we have traffic islands, and the design of traffic islands. And also we should, if we if we require, there may be rotary intersections, like all type of intersections, the diagrams and drawings, and their constructions, all type of information is gathered and placed in the drawing of design of drawings of road intersection. And the last one is land plan showing the quarries. In this land plan showing the quarries, so whatever the quarries are very near to the in the whenever the construction of the alignment. So these facilities are like water and aggregates should be, aggregates means any like soil or anything, so it should be or near is nearer to the alignment or not. So in the finalization of the alignment, so these item also remember are placed in a one point in the finalization of the alignment. So this is the steps generally available in the drawings and report. So